Welcome back everyone to another video in our Fundamentals of Structural Engineering course. In this video, we are going to have an introduction about steel structure design. Steel structures come in many different shapes, as you can see here. There are W, which is wide flange shape, S, which is the American standard beam, and C, the American standard channel, and angles, and hollow sections, hollow pipes, and also plates, many different shapes. In this course, we are going to be focusing mainly on the wide flange shape, which we are going to be using during our design of the beams and for the columns. Here you can see the main properties of a wide flange section. This is what we call the web of this beam. This is called the flange, and of course this is the thickness of the flange, TF, and this is the thickness of the web, T-web. This is the strong axis, of course, and this is the weak axis. This is the width of the flange, and this is the depth of the beam. Here you can see a table which includes all of the data and the properties about this beam or about this section. It could be used as a column, of course. When we see here, this is section called W2468. This means that the depth of this section is 24 inches. As you can see here, it is 23.7, approximately 24 inches. And this 68, it means the weight of this section per meter equals 68 pounds. So the first one is the first parameter is the depth of the section, and the second parameter is the weight of this section. Here, for example, this is you can see it has the same depth, this section, but it is lighter, which means that the flanges and the web, you will find it to be less thick, thinner than the other sections. As you can see here, for example, this is the area here, it was 20.1 inches square. Here it is 18, here it is 16.3, and that's why the weight here is 68, 62, and 55. This is the main sections that we are going to be using during the design of this course. We will be learning the design of columns, beams, and connections. Steel is a very strong material. Actually, it is almost 10 times stronger than concrete. And because of that, the steel elements tend to be very slender compared to the concrete elements. And because of that, we have a new issue in the steel structures. It is also there, of course, for the concrete structure, but it doesn't affect the RC members as much as it does to the steel members, which is buckling. There is buckling in concrete elements also, but this is mainly in long columns and in special cases. But in steel elements, any steel element under compression, you will find that it is almost always governed by the load of buckling, which means that the column is not going to fail due to the strength itself, but it is going to fail because of this buckling, as you can see here. This is in most of the cases that the load for the buckling will be lower than the load required to create total failure for the section itself. And because of that, we have a new term here which is called effective length of member, LC. This is very important, and we will need it through the whole course when we start designing the steel elements. LC, which is the effective length of a member, it equals K multiplied by L, where L is the non-braced length of the member, and K is a factor. As you can see here, we get it from this table. It depends on the boundary condition of the beam or the column or the member itself. If it is connected by fixed support from the top and fixed support from the bottom, K equals 0.5. If it is hinged and hinged, K equals 1. If it is fixed and free, K equals 2, and whatever, as you can see here. And it is going to be multiplied by L, which is the unbraced length. Here, for example, as you can see this column, you can see this bracing here laterally. This bracing, it creates a lateral bracing, but only in this direction, as you can see, because the element is going to be buckling in this shape here. That's why the non-braced length now is only this length and only this length, not the whole length of the member. However, in the other direction, in the major axis, this is actually the whole length is the unbraced length, because we don't have bracing from the other direction here. So when we are designing this member, we need to take care of the KL, or the effective length, in X and in Y direction. And of course, for each direction we could have different boundary condition, we can have different bracing, we can have different unbraced length, all of that as we have just explained. Starting from the next video, we will start learning how to design beams and columns and connections of steel. So that's it for today. See you in our next video. Thank you.